Welcome to This Explainer. Today, we're going to treat your application like a literal fortress. We are cutting through all the noise out there about secure coding and zeroing in on the absolute most important line of defense between your sensitive data and the outside world. Now, our source material makes a pretty massive claim right out of the gate. It says, if you take away one technical skill from this entire course, this should be it. Right? Input validation is not just some minor best practice. It's not just a compliance box you tick off. It is absolutely your ultimate shield against total catastrophe.
So what are the stakes here? Well, the Verizon Data Breach Investigations Report consistently finds that a staggering 25% of breaches involve some form of injection. That's a quarter of all breaches. And here's the kicker. It's not because injection is this incredibly advanced, insurmountable hacking technique. No, it happens purely because developers consistently fail to validate input before they actually use it. Whether we're talking SQL injection, command injection, or LDAP injection, they all share one singular root cause, treating untrusted data as trusted.
Here's the mental model we're building today. We're looking at data as a weapon, the golden rules, the defense pipeline, security as code, and finally, common validation blind spots.
Okay, let's jump straight into part 1, data as a weapon. Let's establish exactly what we're up against.
Just look at the sheer scope of this battlefield. Literally every single piece of data entering your app from the outside world, it's a loaded weapon. We usually just think of things like registration forms, right? But the threat is everywhere. We're talking URL parameters, HTTP headers, cookies, file uploads, even JSON payloads from third-party APIs. It is all completely untrusted.
Which brings us to part 2, the golden rules, the foundational mindset you absolutely need for your defense.
Okay, I want you to basically tattoo this on your brain. Client-side validation is just a UX feature. Seriously, it's fantastic for giving your user instant feedback if they, mistype their email address. But as a security control, it is entirely useless. Why? Because an attacker is absolutely not going to politely use your web form. Somebody using curl or Postman or Burp Suite, they'll just send raw HTTP requests directly to your endpoints and bypass your client-side checks entirely. So you must always validate on the server, and you have to assume every single byte of input is malicious until it's proven safe.
And that brings us to the classic debate, whitelisting versus blacklisting. Look, blacklisting is just a miserable, endless cat and mouse game. If you blacklist the word script, an attacker is just going to use uppercase letters or maybe Unicode escapes, and you're just patching forever. Whitelisting, on the other hand, flips the script entirely. You define exactly what is allowed, like say, only letters and numbers, and then boom, novel attacks are blocked automatically. Basically, nothing gets through the door unless it is explicitly on the VIP list.
Let's move on to part 3, the defense pipeline, featuring the 5 core strategies of validation.
Instead of just doing random security checks whenever you feel like it, you need to visualize validation as a strict pipeline. Syntactic, semantic, type, range, and length. Every single piece of data has to survive this exact sequence. If it fails even one step, it gets dropped immediately.
Let's break down those first 2. So syntactic validation handles the expected format, right? Like making sure an email actually looks like an email, or a date follows standard ISO formatting. But semantic validation, that's where human judgment really comes in. For example, an order quantity of -5 might be a perfectly valid integer syntactically, but semantically, it makes absolutely zero business sense. Automated tools can't help you there. You have to ensure the data actually makes sense for your specific business logic.
Now, these last 3 are pretty straightforward, but they are critical for completing your pipeline. First up, check the type. If parsing fails, like if you get a not a number in JavaScript, reject it. Don't just silently convert it to a 0, reject it. Next, enforce the range by establishing reasonable minimums and maximums for your numbers. And finally, length. Think about it. If your username field lacks a length limit, an attacker could just send a 10 gigabyte payload of the letter A, cause a massive resource exhaustion attack, and completely crash your server. No good.
But wait, there is a hugely important prerequisite here. Before data ever even hits that pipeline, you must canonicalize it. Attackers love to hide malicious payloads using different encodings, like turning a ... into %20e. If you don't decode it to its absolute simplest standard form first, your pipeline might validate a harmless-looking variant, which your app then decodes and executes later. So the golden rule is, canonicalized first, validate second.
All right, part 4, security as code. Let's talk about practical application using modern libraries.
Across every major ecosystem, you should really be relying on declarative, battle-tested libraries instead of trying to write this incredibly complex logic yourself. Whether you're using Pydantic in Python, Joy or Zod in Node.js, or Bean validation in Java, these libraries are designed to just automatically kick back a 400 or 422 error before your business logic even runs. It's security as code. It's readable, it's highly testable, and it intercepts the bad data before it ever reaches your application handlers. Now keep in mind, you can't just apply a standard text whitelist to everything. Different inputs need specialized defense tactics. Take file uploads. You have to actually inspect the magic bytes of the file, strictly limit the size, and always scan for malware. And what about JSON? You have to validate the schema and definitely set a maximum depth limit. If you don't, an attacker can just send a deeply nested object that sends your processor into an infinite recursive loop.
Let's wrap things up with Part 5, common validation blind spots, edge cases, and those pesky mistakes.
These right here are the traps where developers stumble the most out in the real world. We've already talked about skipping canonicalization and the dangers of blacklists, but a really insidious one is simply forgetting that things like cookies and HTTP headers are actually user input. Another classic mistake is writing a sloppy regular expression that triggers exponential backtracking. This is known as RDOS, or regular expression denial of service, and it can literally take down your entire service with just a single carefully crafted string. Crazy, right?
So, to sum up this explainer, please do not roll your own validation code. Rely on mandatory server-side checks. Always use strict whitelists. Enforce that 5-step pipeline. Canonicalize your data beforehand. And lean heavily on those battle-tested libraries. Do all that, and that is how you build an impenetrable fortress.
But, this leaves us with a pretty critical puzzle for next time. Once our gates are fortified and the data inside is perfectly clean and processed, what happens when it needs to leave? How do we prevent our own pristine data from turning into an attack when it renders on a user screen? Think about that for a bit, and stay curious until we tackle output encoding.